Okay, last day, what did we do was valence bond theory, isn't it? And in valence bond theory, you have already done. And in this valence bond theory, what you did was overlapping of orbitals. So I'll just give you some more examples here. If I say water molecule contains hydrogen and oxygen. So your main atom is oxygen. Oxygen has 1s2, 2s2, 2p4, isn't it? So 1s2, 2s2, 2p4, these are filled up. What is left is this one. You saw it last day also, isn't it? So here, what will happen? How many electrons are there? 4. So 4 electron means 1, 2, 3, and this is 4. So px is filled up, py and pz are still left, isn't it? So py, pz are still left means they are the ones which will overlap, isn't it? So if I take it like this, px, suppose this is your x-axis, then this is your px, and this is your py, isn't it? This is your px and this is your py. Now this px, py have to overlap with what? Hydrogen. Hydrogen is simply a spherical one. So one hydrogen is 1s1. So this can easily combine with one of the p's, isn't it? So when it combines with one of the p's, then in that case, what will happen? When it combines with one of the p, it can overlap with one, isn't it? But the other one is still left. That means we need 2 hydrogens. So one of them overlaps with this, other one overlaps with this. So if I take the overlapping here, then what will you get? This overlapping, I can represent it like this. This is the x-axis and y-axis. X-axis overlapping with S will form you this. Last day only you have seen. And y-axis overlapping will form this, and this will become smaller, isn't it? This is x-axis, y-axis. So what you can see here, x-axis and y-axis, the overlappings are taking place, but this axis, the things are directed along x-axis and y-axis. So if I take the molecule, I'll write O, H, and H, isn't it? So this angle will be how much? Tell me. According to valence bond theory, this angle should be how much? The angle between OH and this angle should be how much? If you take it here, this is x-axis, this is y-axis. So this is between x and y-axis, isn't it? So that's why what will happen? X and y-axis, what is the angle between them? They are perpendicular to each other. So this one is showing that it should be 90, isn't it? According to this theory, it should be 90, but this 90 is wrong. Experimentally, it is found to be 104.5 degree. So whatever you are getting experimentally and whatever you are getting theoretically, they're not same, isn't it? They're not same. That's why what will happen? The things are not matching. So some drawbacks are there, isn't it? That means valence bond theory can explain how the bond is formed, but it cannot explain the structure of the molecule, isn't it? The angle which is supposed to be 104.5, according to this theory, it is coming to 90. So it is wrong, isn't it? Same thing happens when I take ammonia molecule. If I take ammonia, now what you have? Nitrogen is your main thing. So nitrogen is 1s2, 2s2, 2p3. These are filled up. P will have how many electrons? 1, 2, 3. Px, PY, PZ. All three are vacant here, isn't it? Now, if I see the same type of overlapping, then PX will overlap with one of the S, PY will overlap with one of the S, and PZ will overlap with one of the S, isn't it? So when it overlaps, what will happen? When this overlaps, what will happen? The axis is along x-axis, y-axis, and z-axis. This is x-axis, then this I'll say y-axis. Z-axis is perpendicular. So what will happen? This is p orbital overlapping with this, then this will be smaller one, isn't it? This overlapping, so this will be smaller, and same way the other one also overlaps. This side it will be smaller, so it will be like this. So your bondings are between x-axis, y-axis, and z-axis. So what I can say here, if I say this is hydrogen, this is hydrogen, and one will be perpendicular hydrogen, isn't it? One of them will be perpendicular. So here also, according to valence bond theory, this is coming to 90 degree, but this 90 degree is wrong. The experimental angle is 107 degree. So here also it is not matching, isn't it? So what happens when I take this water or ammonia? They're not matching, isn't it? The bonding, how the bonding takes place, it can easily be explained, but how the angle, or how much is the angle, that cannot be explained. Is it clear? So to explain these things, we have some other things, some other theories are there. So we have to look into those theories. Clear? So to look into those theories, one more thing before that I'll tell you. Suppose I say carbon. Carbon can form so many compounds, isn't it? Carbon is 1s2, 2s2, 2p2, isn't it? So this is filled up. How many unpaired electrons? It has only 2 unpaired electrons. Px, Py, Pz is vacant only. So since Pz is vacant, Pz will not combine with anything. It does not have any electrons, so it will not combine. So hence what I can say, Px and Py will combine, isn't it? So only 2 bonds it should make. If 2 unpaired electrons are there, 2 bonds, because these 2 are filled up as usual, as we used to say, these things are filled up. That means only 2 bonds means its valency should be 2. But you all have already studied in class 10 also. What is the valency of carbon? The valency of carbon is 4. But here you are getting the valency as 2. So why you are getting this? This has to be explained. So this valence bond theory could not explain the tetravalency, like valency of this is 4, carbon is 4, but it could not explain why carbon exhibits tetravalency. Clear? So to explain that, we'll see some other theories, and those theories, if I take it, then in that case, I can take another thing called hybridization. So we are going into a new theory. That new theory is called hybridization. You have already heard the word hybridization, isn't it? What is hybridization? In plants and animals, you have already studied. That means in biology, you have already studied hybridization. What is it? Hybridization, it is mixing up of 2 species, 2 different species are mixed up, and you get a new type of species, isn't it? So this new type of species, they are the hybrid species. So same way here, when we are using the same concept in chemistry, so what we are going to do, we have atomic orbitals here now, isn't it? So these atomic orbitals, they are going to mix up. Yeah. So what will happen? In each atom, you have a atomic orbital. Those atomic orbitals are s, p, d, and f. These atomic orbitals, they mix up, they hybridize, and when they hybridize, what will happen? They form a new type of orbital. They are called hybrid orbitals. So I'll give you first few points, and then we'll see this theory. So what I can say, atomic orbitals. Atomic orbitals means s, p, and other things, isn't it? S, p, d, f, all those things. So atomic orbitals uh, mixes up with each other to form a new type of orbital. They form a new type of orbital called hybrid orbital. Yeah, atomic orbitals, they mix up with each other, and when they mix up, what will happen? They form a new type of orbital. That new type of orbital is called hybrid orbital. Now these hybrid orbitals, if we study, they do not have the properties of the two which are mixed up. Here S can combine with P or D, isn't it? So when they combine, what are the different types of hybridization? We'll see that, but before that, these things. Now, when atomic orbitals combine, can any two atomic orbitals combine? Because in an atom, we have many orbitals. Can any two combine? It's not possible. What will happen? Atomic orbitals having almost same energy. Atomic orbitals having almost same energy. What do they do? Hybridize. So not all, those which have almost same energy, they can hybridize. Clear? If the energy difference is more, the difference in energy is more, then they cannot hybridize. Clear? So they must have almost same energy. Energy difference should be very small, isn't it? That is energy difference between the orbitals should be very less. Yeah. If it is very less, then what will happen? If it is less, then it can hybridize. If it is more, then it cannot hybridize. Clear? So if the difference of energy between two orbitals are large, if the difference of energy between two orbitals are large, then they cannot hybridize. Clear? So for hybridization, the energy difference has to be less. Energy difference is less, they can easily hybridize. Understood? Okay. Then the next thing, if I take the next point, what is happening here? Atomic orbitals, they are combining. So it can be one atomic orbital, two atomic orbital, any number of atomic orbitals can combine. So when they combine, they form the same number of hybrid orbitals. Suppose two atomic orbitals are combining, they'll form two hybrid orbitals. If three are combining, they'll form three hybrid orbitals. So what I can write down? The number of atomic orbitals combining is equal to the number of atomic orbitals combining is equal to the number of hybrid orbitals formed. So number of atomic orbitals combining is equal to the number of hybrid orbitals formed. Understood? Have you all copied? Then we go to the next point. The next point, if I take, then in that case, what happens when they're combining? We said three are combining, three are formed, isn't it? Now, when atomic orbitals are combining, they can be of different types. But when hybrid orbitals are formed, they all are identical. So, the hybrid orbitals formed by a particular type of hybridization. The hybrid orbitals formed by a particular type of hybridization are all identical in all respect. They're identical in everything except their orientation. Everything will be same. Suppose four hybrid orbitals are formed, four atomic orbitals combined, four hybrid orbitals are formed. Then all four will be exactly same. There will be no difference between them except the directions will be different. They cannot have the same direction, isn't it? So the directions will be different. Otherwise, everything will remain same. Clear? So hybrid orbitals formed by a particular hybridization. We'll see that when we are talking about, when we are taking the examples, we'll see that in details. Clear? And then another very important point is, if I take this hybridization, whatever hybridization, a particular hybridization is taking place, then that particular hybridization gives a particular geometry to the molecule. So a particular type of hybridization gives a particular geometry meaning shape to the molecule. So whatever is the hybridization, accordingly, what will you have? You'll have the shape of the molecule. So if I say this hybridization, immediately you can say this hybridization will form this type of structure. Understood? So this is your hybridization, different points. Clear? Atomic orbitals, they combine to form hybrid orbitals. Hybrid orbitals, when they are formed, all hybrid orbitals are identical. Atomic orbitals, when they combine, only those can combine which have almost equal energy, isn't it? And if two are combining, then two hybrid orbitals are formed. Three are combining, then three hybrid orbitals are formed. So that thing you have to remember. Understood? So these are the different points. Now from these points, I'll show you one example and then we'll see all the different types of hybridization. So let's talk about this example. Let's take carbon. Just now we said carbon, isn't it? So tetravalency of carbon, I can explain it. On the basis of hybridization, if I want to explain tetravalency of carbon, then what I have to do? I'll take it like this. Look here, carbon just now we said is 1s2, 2s2, 2p2. So if I take it, it is in this form. 1s, 2s and 2p. This has 2 electron, 1 and 1. Understood? Now what will happen? Normally 1s and 2s, the energy difference is very high. But 2s and 2p, the energy is almost same. So what I can say, these two difference in energy is very less. Why? Because both belong to the same shell. So the difference of energy is less. So since the difference is less, these two can easily combine. So what can combine is this 2s and 2p. So this much they can combine together. So when they combine, this is left out as 1s only. It has 2 electrons. And now the remaining, how many are combining? 1, 2, 3, 4. Excuse me. 1 of the S and 3 of the P's are combining, isn't it? So 1 S and 3 P's, that means altogether 4 are combining. So I'll write down how many will be formed? 4. 1, 2, 3, 4 are combining. So 1, 2, 3, 4 are formed. So what will happen here? We'll fill up electrons. How many electrons were there? 1, 2, 3, 4. So these 4 electrons will fill it here. So how will they be filled? 1, 2, 3, 4. We are following Hund's rule. Clear? So since we are following Hund's rule, first it has to be occupied singly because all these 4 are exactly identical. That's what we wrote, isn't it? And then this type of hybridization, what do we call it? This is 2s and p. How many p's are combining? 3. 1 orbital of s and 3 orbitals of p are combining. So this is called sp3 hybridization. sp3 hybridization means what? 1 of the s and 3 of the p's are combining. If I write sp2, 1 of the s and 2 of the p's will be combining. Clear? So that way, whatever is combining, accordingly we name it. Done? So now you can count how many unpaired electrons. Previously there were only 2, so valency we said it should be 2. But now how many unpaired electrons? Number of unpaired electrons is how much? 4. So its valency is also 4. So this is how you are getting it. Is it clear? So tetravalency we can easily explain on the basis of hybridization. There can be many different explanations for this. Clear? But this is, we are using hybridization. So what has happened here? 1, 2, 3, 4 unpaired electron. Why did we get? Because these two, they have combined. Initially this was S, this was different, and this was P. It was completely different. But these 4, they are all exactly same. All 4 are identical, and therefore each one has a unpaired electron. Understood? So this way tetravalency of carbon can be explained. Now from here, what will happen? This can combine with different things. So if it combines with hydrogen, as we saw the previous things, this can combine with one hydrogen. This will also combine with one hydrogen, another hydrogen, another hydrogen. So how many hydrogens they can combine with? 4, isn't it? So when they combine with 4 hydrogen, what will happen? It will have the formula CH4. You know, CH4 is methane, isn't it? So methane, what type of hybridization it has? sp3 hybridization. Clear? And this methane, sp3 hybridization is there, isn't it? If you take this 4 things, the orientations are completely different. So how are they oriented? They will be like this. If I take the orientation, it is like this: 1, 2, 3, and 1 coming in front. So these angles are now fixed. This angle is 109 degree 28 minutes. So there are 4 different things. The angle is how much? 109 degree 28 minutes, or you can say 109.5 degree. Understood? 60 minutes makes 1 degree. So this angle is that much. What will happen here? Each one is combining with hydrogen. In case of methane, this will combine with hydrogen. So what will happen? This will give you the methane molecule. Clear? So if you talk about methane, these are the different bonds. So methane, when I draw the exact structure, it will be like this. This and this, suppose they are coming in front, then one of them is going at the back. This one we cannot see because it is going backwards. So it will be covered with the carbon itself. Understood? So this will give you the tetrahedral structure. So whenever sp3 hybridization takes place, the shape will be tetrahedral. So the shape is fixed, the angle is also fixed. Understood? The shape and angle, both of them are fixed. So that's what we said. Whenever a particular hybridization takes place, it gives a particular geometry to the molecule. So here sp3 hybridization, whenever it is sp3, it will always be tetrahedral, and the angle will always be 109 degree 28 minutes. So this is always fixed. It does not change. Understood? So this is your tetravalency of carbon. You can easily explain the tetravalency of carbon. Understood? Then I'll just explain you once more. For that, this is very important. Tetravalency of carbon. We are taking the hybrid atomic orbitals. So one is has 2, 2s has 2, 2p has 2. So 2 unpaired electron, the valency should be 2, but actually it is not 2, it is 4. So what happens? 2s and 2p, the energy difference is very less. So these 2s and 2p, they combine. So 2s, 2p, they are combining because the energy is less. And the next thing is when they are combining, one of the s and 3 of the p's are combining. So they are forming 4 hybrid orbitals. It's formed by the combination of one of the s and 3 of the p's. So it is called sp3. From the name itself, you know, one s is there and 3 p's are there. So sp3 hybridization. This we read it sp3. Clear? In this case, all these 4 orbitals which are formed, they're exactly identical. Yeah, and these orbitals we are filling up will follow Hund's rule. Since they are identical, energy is same, therefore they are filled one at a time. So 1 year, 1 year, 1 year, 1 year. So one at a time. So what will happen? You get this sp3 hybridization. Understood? So this sp3 hybridization gives 4 unpaired electron. That means the valency of carbon is 4. And with this valency 4 carbon, if I take a example, it can be methane. Carbon is here. These are the orbitals. They are overlapping with hydrogen. This angle, remember it is a 3-dimensional structure. The angles, all the angles, whether I take this angle, this angle, this angle, or this angle, whichever angle, all angles are this much. All angles are 109 degree 28 minutes. Yeah, these are in tetrahedral in shape. Yeah, so these all points you have to know. Understood? So hybridization, I can give you some more examples of hybridization. Clear? And what happens to its geometry and other things. So just a few things I can tell you. Suppose I write sp hybridization. Suppose I write sp hybridization. What does it mean? 1s and 1, it's not 1s, remember, I can say 1s and 1p orbital, they are combining. Here it can be 2s 2p, it can be 3s 3p, or 4s 4p, anyone, but only one orbital of s and one orbital of p are combining. If if I say sp2 hybridization, then one s orbital and 2 p orbitals are combining. One s orbital and 2 p orbitals are combining. sp3, you saw it just now only. sp3 means one s orbital and 3 p orbitals, isn't it? If I write dsp2, then dsp2 hybridization means one d orbital, one s orbital, and 2 p orbitals. These are combining. So You can see different things are combining at a time. So when they mix up, whatever is formed, they all will be exactly identical. Clear? This was different, this was different, this was different. But when they combine, I'll write all of them together. 2, 3, 4. 4 things are formed means all 4 will be exactly identical. Yeah. If I had given you like this, D2SP3, I could have given like this, or SP3D. Anything I can write down, isn't it? So if I say this one, that means 2 d orbitals, isn't it? 1 s orbital and 3 p orbital. These are combining. So how many will they form? If these are combining, 3, 4, 5, 6 are combining. So how many will be formed? 6 will be formed, isn't it? 6 of them are combining, so 6 of them will be formed. Understood? So this way, different hybridizations. These hybridizations, the orbitals are identical, but their properties, I told you, they'll give a particular shape to the molecule. So let's see what shape it can give. Is it clear? These all, they give a particular shape. So what shape it gives, we'll see that. Understood? So let's see one by one. So we'll see this different hybridizations and how they give a particular shape to the molecule. So let's write down these things. I'll write down type of hybridization. What are the different types of hybridization? Then the next thing I'll write down number of hybrid orbitals. Whatever atomic orbitals they combine, the same number of hybrid orbitals are formed. You know that, isn't it? So number of hybrid orbitals. The next thing, if I say, will be geometry, or I can say the shape, what shape it will give. Okay, then bond angle. The bond angle is fixed, I've told you, isn't it? And the last one we'll see is an example. For each of them, we'll see one example. Understood? So let's see one by one what they are. Okay. You know, we'll start with the smallest one, that is SP. You can have a hybridization. That hybridization, we can call it SP hybridization. This SP hybridization, the number of hybrid orbitals, how many will it be? One of the S and one of the P are combining. So only 2 are combining. So what will it be? The number of hybrid orbitals will be 2. Now whenever only 2 things are there, that means what will be the geometry? Only 2 things are there. 2 points if I take and join them, what will I get? I'll always get a straight line. So this will always be linear. It will always be in a straight line. And since it is a straight line, what will be the angle? Straight line, you know the angle. The angle will always be 180 degrees. Linear means 180 degree. And one example where you find sp hybridization, that is ethyne C2H2. C2H2. Clear? C2H2 gives this structure. So what is the structure? You know it. H dash C, triple bond is there, and then H. You know this angle is how much? This angle will be how much? 180 degree, like what we saw. And all the things, hydrogen, carbon, carbon, hydrogen, all of them will be in the same straight line. They all will be in the same straight line. Clear? Then let's take the next one. You have sp2. One more p we have added. So how many hybrid orbitals? Here 2p and 1s. So altogether how many are combining? 3 are combining. So how many will be formed here? 3. 3 orbitals are combining. So 3 hybrid orbitals are formed. Isn't it? So this one, if I take that, what will it be? The shape, it will be planar. Yeah, and 3 things when they are arranged, you can say trigonal also. So you can also call it trigonal planar. Trigonal planar. This will have a bond angle. Here the bond angle will be 120 degrees. The bond angle is 120 degrees. And an example we can take is ethene. Ethene is C2H4. C2H4, if you see, it is like this. So these angles, how much? Whether you take whichever angle you take, it will all be 120 degrees. All the angles will be equal to 120 degrees. Understood? Then the next one. Okay, now look here, the next one. The next one I'll take is sp3. Just now you saw. sp3 will be how many? 4 are combining. What will be the structure, shape? Tetrahedral. What will be the bond angle? I've already given you 109 degree 28 minutes. An example, you can say methane, that was CH4. We already saw that. Apart from this, you can also have ethane C2H6. So if I give you C2H6, two of them, they're combining like this. These all angles will be how much? 109.5 degrees. 109.5 degrees. Is it clear? So this we have already done. Then next I'll take is DSP2. DSP2. Now when I take this DSP2, how many hybrid orbitals? Here they are again 4 only. This was also 4, but that gave tetrahedral. This is also 4, although the things are different. It is still 4, but what will happen? The shape will be different. This will give you square planar. It'll just be a square plane one. This one, the bond angle will be 90 degrees. The bond angle will be 90 degrees. And then when I take an example, I can take CuNH3 4 2 plus iron. If I take this, copper is there, then you have ammonia attached to it. These are complex compound.
ফোন বাজছে।
তুই এই যে মাথাতে ঝুলটা ভালো মতো মাখাচ্ছিস নাকি? ঝুলি তো ভর্তি গিয়েছে। কি শুনছিস না? বন্ধ করে দিয়েছিস? কি বইটা শুনছিস নেই?
এখন স্টপ আছে।
Okay, all of you can hear me now, isn't it? There was someone at the door.
Yes, sir.
Okay, we'll continue now. Here, what I gave you here, each angle, these all angles will be how much? 90 degrees. Each angle will be equals to 90 degrees. Okay, so this is an example of square planar. Understood? Then we have some more. You can have D2SP3, or the same thing can be SP3D2. Here the inner D can be used or the outer D can be used, but in both the cases total number of things are 6. So D2SP3 and SP3D2, there is some difference, but at present you don't have to know that difference. Later on we'll see. So both are similar, 2 Ds, 3 Ps and 1 S, isn't it? So altogether 6. So 6 gives a octahedral structure. This octahedral structure, the bond angle again is 90 degree, and here we can take SF6, sulfur hexafluoride. Sulfur hexafluoride. Is it clear? So sulfur hexafluoride, if you take the structure, it is like this. S, there are 4 fluorines forming a square. These 4 fluorines are forming a square. If I join them, this is a square. Okay, and 1 fluorine just above and 1 fluorine just below the plane. So this is your example of SF6. You can see here each angle is how much? 90 degree. This angle, each angle is 90. The only difference is this is one plane. This is just like your book. This is suppose your book, and this one is above your book, and this is going perpendicular below your book. So these two are above and below. This is your flat book. So what will happen? These all angle, whichever angle I take, all these angles are 90 degree each. Yeah. So this is your octahedral structure. Understood? Then one more we have, that is SP3D. SP3D. Clear? So this SP3D has only 5. You can see it is different from the other one. So this has 5 means this will be trigonal bipyramidal. bipyramidal. Bipyramid means it's just like a pyramid, but there are two pyramids attached to it. Here, the bond angles are also different. You have 90° also, and you have 120° also. Now this 90° is something similar like this. This is above and below. These are the axial one, and these are on the same plane. So these are called equatorial. So this 90° is the axial one, and this one is equatorial one. So axial ones are 90°, and the other one is 120°. Example you can take is PCl5, PCl3, PCl5. These all are sp3d hybridization. So this will have a structure. What will be the structure? Now look here. P will be in the middle. You'll have 3 chlorines forming a equilateral triangle. So this is one plane. As I told you, this will be one plane, and above the plane you have Cl, and below the plane you have Cl. Clear? So these 3, 1, 2, 3, these 3 are in equatorial position, and these 2 are the axial positions. Clear? As I told you, P, this is Cl, Cl and Cl. These Cls are equatorial on the same plane. They are on the same plane, and then the same P, I have just separated it, is Cl and Cl. These are axial. That means perpendicular to the plane. These 2 are perpendicular to the plane. So this angle, the equatorial angles, this angle, or this angle, this all will be 120°. And this with this one, if you take this angle, it will be 90°. So equatorial angles are equatorial angles are 120° and axial angles are 90°. Clear? So these things you have to know. Understood? Have you all copied all these things? Have you all copied? So these all things, whatever examples I've given you, these things you have to learn. Apart from this, just for you to remember what I can say, whenever you have a single bond, carbon-carbon single bond, that will always be sp3 hybridization. Whenever there is a double bond, it will always be sp2 hybridization. Whenever there is a triple bond, it will be sp hybridization. Some commonly asked things, if I say diamond is made up of carbon, graphite is also made up of carbon. Diamond and graphite, the structures are completely different from each other. Why? Because the carbon here, they are differently hybridized. Here it is sp3 hybridized, and this is sp2 hybridized. So this becomes tetrahedral, whereas this becomes planar. So since this is in a plane, the layers are there. Okay, so that structure we'll see later on in details, but this at least you should remember. Understood? So these are the different types of hybridizations which you have to know. I'll quickly show you once more. Yeah. So if I show you once more, you have the different types of hybridizations. What are they? You have sp hybridization. It has two hybrid orbitals. It is linear. Angle is 180. Ethine is an example. The other one is sp2. Three hybrid orbitals, isn't it? That means three atomic orbitals are combining. It is trigonal planar. The angle is 120 degree, and example is ethene. Clear? The structures I've already shown you. You should know it. Then we have sp3. sp3 is tetrahedral, 109.5 degree. The bond angle, tetrahedral structure, methane and ethane are examples. Then D2sp3 or D2, oh no, before that we have done the other one, that is DsP2. DsP2 is also 4, but that is square planar. The bond angle is 90 degree. Copper ammonium, tetraammonium. That is an example, isn't it? So NH 4 of the NH3s are in the form of a square. So they are called square planar. If I write like this, Cu, you'll have NH3, NH3, NH3 and NH3. These all forming a square. That's why they are called square planar. These all are in the same plane. Understood? Then you had the next one, D2sp3. D2sp3 is similar to sp3d2 that has 6 electrons, 6 hybrid orbitals. It is octahedral. 90 degree is the angle. And example is SF6, sulfur hexafluoride. So here you have a square in which 4 fluorines are there at the corner, 1 fluorine exactly on top and 1 fluorine below. So these 4, they are, the 4 of them, they are equatorial, and this, they are axial. Yeah. So 4 are equatorial, 2 of them are axial, but all angles are 90 degree. All angles, whether it is equatorial or axial, all are 90 degree. Then we had sp3d. sp3d, 5 hybrid orbitals, trigonal bipyramidal. The axial angles are 90 degree, the equatorial angles are 120. Now what are these axial and equatorial that I have explained in this example? ECl5 is an example. 3 of them, they form a triangle, equilateral triangle, isn't it? So this is your equatorial one, and 2 of them, they are perpendicular to it. So these are the axial ones. So this is a structure, isn't it? And then finally, I told you, for your reference, whenever there is a double bond, single bond or triple bond, then you can easily state what type of hybridization they have. A single bond has sp3, double bond has sp2, triple bond has sp. Oh wait, here, this is only sp. Here, this is sp3, single bond. Double bond is sp2, and triple bond is only sp. Then diamond is sp3, graphite is sp2. So this is your theory. All about the theory we have done. We'll be using some examples and seeing this, and then this also has some drawbacks. We'll see that next day. Yeah. So today you all do this much. Go through all these things, whatever is there, go through it, revise it. Next day we'll continue with it. Understood? Any problem, all of you? No. So you'll revise all these things. Next day we'll see. Yeah. So thank you, all of you.
Thank you, sir.